Welcome back, YouTube. We are about to start another exciting episode of Orion Homestead Project. This is going to be a tech edition. I'm calling this one Wilderness Wi-Fi, and I'm going to focus the first part of this on an overview of what I'm using and how I'm using it, and we'll see how much we can get done. I have no idea right now. We're just starting it, so we'll see what we can pull together and get some insight for you on. So with that, let's take a walk and see what we got going on. Alright, with that, let's get this started. We're going to run through a quick overview of all the components that I'm using and how they're going to be interconnected. Created this mock-up yesterday while I built my equipment cabinet to try to run through and show you all the different components that I'm using to make my Wilderness Wi-Fi a reality. I sure hope this works. But at any rate, so most of this stuff is connected. It's connected using very short cables. This is not the final configuration. I'm going to translate all of the things that you see here into my equipment cabinet, and I'll show you that in a second, and then I'll show you where it's going to go as well. But first, let's start out. The heart of the entire system, right, is this device right here. This is my router. It allows me to take two different WAN inputs, internet connections, feed them into the router, which is what these connections are. They use 10 gig SFP plus inserts right here. So I've got one that goes to my Starlink right here, and I've got another one that will connect to the LAN interface on my Wi-Fi hotspot. So at this point, I have cellular and satellite internet service that will be coming into the bus. So these are my inputs. Then I have my outputs. So I have this output right here, which goes up to my TP-Link Wi-Fi extender. I'm going to be using this as an access point. This will be the sole source of Wi-Fi access inside the bus. And it will be directly connected to the router over LAN cable. The next two connections that you see on the router are the uplink ports to my distribution switches. I have one for the front of the bus, and I have one for the back of the bus. And I need to do that so that I'm not trying to run 20 cables from the front of the bus all the way to the back. So I'll run an uplink cable from the router to the front switch. I'll run an uplink cable from the router to the back switch, and then from the switches we'll do the distribution to the various ports that I'll be installing throughout the bus. The actual next connection is this one right here. This one is the LAN input of my PoE injector. The output of the PoE injector goes through this long cable, comes around, comes back, and goes up to this thing. This is where Wilderness Wi-Fi came into being. This is a Wavlink Wi-Fi extender. This will actually extend Wi-Fi 300 meters. So it will be sitting, when it's all said and done in the final installation, I've already had it up there, but it will be sitting somewhere in the neighborhood of 13 to 15 feet above ground level, up on top of the bus. Guys, one of the main reasons why I'm doing this, and I'm trying to make sure that everything is hardwired, both for my internal Wi-Fi and my external Wi-Fi. The external Wi-Fi serves two purposes. Number one, it allows me to keep my security cameras operational and be able to see what's going on with them no matter where I am, no matter what I'm doing, because this will actually pick up the signals, translate it into the bus over the internet and to a web page where I can see the cameras. This is the sole source of Wi-Fi inside the bus. One of the challenges that I faced using my hotspot to try to work my security cameras and connectivity and speed checks and all of that stuff is that this bus is a tin can. It didn't help that I have gone through and put reflectix in all the walls and all the ceilings. It is almost impossible to get an electromagnetic signal from the outside world inside this bus. I can take my hotspot where it normally sits and get anywhere from 5 to 9 megabits per second upload and fails on download, or download and then fails on upload. If I put that same hotspot in a window on the right side of the bus, depending on where the signal's coming from, I get 200 to 400 megabits per second on that same device within minutes. So this bus is attenuating any external outside electromagnetic radiation. So what I'm doing is I'm using a wired network to more or less provide transmission medium outside the tin can and get to the open air. The hotspot, I have a mounting system similar to this right here. It's a suction cup for the hotspot. This one is a screw-in. I've got other ideas for this one, but what I'll be able to do is I'll be able to take my hotspot and do a suction cup mount as I'm going down the road, put it on the front windshield, and if I need to move it around, relocate it or whatever to get the best signal possible. And the glass doesn't seem to attenuate the signal as much as all the metal and the reflectix and everything else. So let's go through a few other things. So here is my Starlink router. When I put this in and power it up, it is going to be in bypass mode. I only want the internet connection to come in and go out the Ethernet cable that I have connected to it. It'll go from here to the input here. The other thing that I've done is, if you notice, I've got this power supply right here. This takes 12 volt in and puts out the 54 volts that the Starlink needs. I have a serious issue taking DC power from my batteries, converting it to AC through my inverters, and then plugging a device through a power supply that plugs into a wall jack that converts the AC power back to DC. So basically I just got these converters which eliminates that AC to DC, DC to AC conversion, and I'm sorry, DC to AC, AC to DC conversion, and just goes straight from DC to DC. Much less power draw, much more efficient. This one is dedicated to Starlink. This one right here is the exact same thing. It's a duplicate. It's not dedicated to Starlink. It doesn't have the fancy Starlink cable on it or anything. It's just got 12 volts in and 54 volts out. I'm using this one. As you can see, I've already got it connected, providing power to the PoE injector on this device from a Wavlink. I've also got this cable over here. It's also 54 volts. This is the power supply from my router, so I am going to be cutting this, stripping it back, and making connections so that I can connect this to this so that it goes straight from 12 volts to 54 volts as well. So everything in here that I'm installing runs off of DC, even my distribution switches. As you can see, they have a DC power input right there. The beautiful thing about these is they offer the ability to have redundant power, so I could actually run 12 and 24 volts. Haven't made up my mind if I'm going to do that. I could also do bus and house, not sure. At a minimum, I'm going to just power them up off my bus batteries. So one of the other things that I want to share with you is, so I've got my uplink cable that comes into the switch. These are my distribution ports. This is an unmanaged switch, so basically it's plug and play. Put internet in, plug things up, it automatically connects. There is going to be a method to my madness. I've got 9 ports, and what I'm going to do is orient these switches in their install location, and based on that orientation, front or back, left or right, doesn't matter, The first 5 ports will be one side, the remaining 4 ports will be the other side, and I'm going to orient them based on the port count that I need on each side. This one is going to be for the front, or one of them will be for the front. They're identical, but one of them will be for the front and provide distribution to the front cable, front part of the bus. The other one, I'll run a single uplink cable from the front of the bus to where I mount this, and then the distribution on this will take care of the back of the bus. That way I'm not trying to run basically 18 Ethernet cables from the front of the bus all over the place, trying to get to everything. Because, like, as you can see right there, I'm not getting any more cables through there, guys. It's crammed up and jam packed. So I've got to figure out how to get the distribution out of these switches, but I'll be working that. I will get everything run and routed so that everything is distributed throughout the bus. So bottom line is, anything that has a network interface card that can be hardwired into a LAN will be. Case in point, my Servo GXs, they're currently connected over Wi-Fi to my hotspot. They're constantly dropping in and out. They will be hardwired over the LAN connection. Beautiful thing about those is that they will also have a wireless connection to my TP-Link, and if my primary network fails, they'll still be able to get wireless connection off the TP-Link, from whether that be from the hotspot or Starlink. And the beautiful thing about this is that, like, going down the interstate in urban areas where there's a lot of cell towers and a lot of cell phone signal and all that, my hotspot is probably going to be providing a 5G UC signal, which will be much better than my Starlink input. I'll still have Starlink input, and that router will load balance, but the fastest connection will be my hotspot. And I have unlimited roam on Starlink, and I have an unlimited plan on my hotspot, so I'm not worried about running out of data or anything like that. That will help out tremendously. Because everything is hardwired, I do not have to worry about RF radiation penetrating from the outside to the inside. One of the other things that I want to point out, here is all of the hardware that I'll be using. This is a sampling, it's not everything I have, but I've got single port and double port wall plates with shallow wall jacks, and I've got the feed throughs that will plug in, the keystone adapters that will plug in, and then I'll be running the distribution cables from the switches to these, and then I'll have patch cables available that will run from these to whatever device needs to be connected or whatever. Here's all my security cameras. This is the primary reason why I've decided to do this wilderness Wi-Fi setup, and being able to translate RF or internet signals from inside the bus to outside the bus, is because I already have some of these installed, and the signal from the inside of the bus to the outside of the bus is not enough to support the video bandwidth for these, and they keep dropping offline. One of the other challenges that I have is these will be connected. Well, this is an internal camera, so this will be connected to my TP-Link. These are external cameras, so they'll be connected to my Wavlink. One of the other challenges that I have is the only way to change a Wi-Fi setting on these cameras, so with these 2 and the 4 that I already have installed, there's 6 cameras, is to do a factory reset. So if I put all 6 of my cameras on my Wavlink, regardless of what my internet source is, they will always be connected to this. One of the things that I'm going to try to figure out and do some testing on, if I put this in its mounting location on the top of the roof, the top of the antennas, as you can see, they're way up here. It's too high. I have very serious clearance limitations if I leave that vertical. So what I'm going to actually do is actually do a test and see if I can lay this thing over and securely mount it for travel, and have it function enough to be able to still keep my security cameras operational if I'm going down the road. One of the other things, I have a Starlink Gen 3 standard. I have unlimited data, and I have data in motion on it, so I can use this while I'm rolling down the road as well. So if I have Starlink but I don't have cell signal, I still have data. And that pretty much covers everything from the overall equipment perspective. The last thing that I want to point out is, as you can see, this is my Wavlink. It's going to be going on the roof. It's got a watertight connection right here. And then I've got a little short 6-inch patch cable that comes into this watertight connection right here. One of the things that I've done, because if I do have to remove this off the roof if I'm traveling, or for any reason if I have to remove my Starlink antenna off the roof for whatever reason, then I can basically disconnect the input cable from here. And I created this little device right here. It's got an old Cat 5 cable in it, but it's sealed and solid. You can see the cable inside. So all I do is I screw this on, and actually, I'm sorry, screw it on this way to this cable end, because this cable end is actually going to be tied to power, both for the Wavlink and the Starlink. So I've got one for Wavlink right here, and I've got one for Starlink over there. So I connect this to the end of the cable, not connected to the other cable, but it provides a waterproof connection. So if I forget to turn it off and there's power on this cable, I don't have to worry about it getting wet, shorting out, or anything like that. So I just did this to give me some insurance and make sure that I didn't have any water problems. This is the part that will be removed when I do it that way. That way there's no connections between the cables, and it's just a watertight seal. Actually on this will stay in, and it will be connected on the top side. I mean on the bottom side. It just will not be connected on the top side, because what will happen is this will replace this. No connection. So there's that. The other thing is, I wanted to show you and give you an overview of what those look like in their full form. I've done a couple of 6-inch patch cables and broken them apart and showed you how they all come together. I will tell you that because of these latches and stuff, getting these to feed through these holes sometimes is a challenge. You just got to manipulate it. They will go through, but it is not always easy. So bottom line is, you have the cable coming through. This is the locking collar. This is the water seal. And this water seal goes inside of here, and when you tighten this down, it squeezes down on that and squeezes this around the cable so that it doesn't leak. Coming up into here, this is the cable connection that goes through the feed through right here. You connect this to this and tighten it down, and this seals up against this blue gasket that you see right here. Same thing on the other side. Put it all together, it looks like this with a watertight seal. I don't have this connected because I was playing around with this, but or I don't have it tightened down, but it creates a watertight seal all the way through from beginning to end, and theoretically no water can get in there. I haven't really tried it in weather yet because I'm just now pulling all this together. I'll have one for this, and I'll have one for this for my Starlink cable that'll be on the roof. And with that, I think I've covered everything. If you have any additional questions, comments, what I will try to do is put a parts list in the comments below so that you can see everything I used, and if it suits your fancy and you want to try to duplicate it, you'll have everything that I used so that you can do it. What I do want to show you now, though, is the equipment cabinet that I built yesterday. That all of this stuff, well, not all of it, but most of this stuff is going to go in and provide the mounting for all of this hardware. And then after I show you the cabinet, I'll show you the location where it's going to go. And then the next step will be actually getting all of this stuff installed into the cabinet. All of the cables are routed based on the correct distances. Like right here, I've got a 6-inch cable from here to here. This is definitely not going to be 6 inches away from the router unless I can get lucky, but Anyway, so let's take a walk. Let's go look at the equipment cabinet that I built yesterday and got it prepped, ready. I've already dry fitted it. I know it works. I know it'll work. So let's go look at it. All right, well, there it is. This particular piece of wood right here is a duplicate of this piece of wood right here. It's going to go right here, sitting like this, and provide that right there. One of the things, once I get this mounted, I had to leave this off for right now. I notice I've got that one on, but I had to leave this one off because when I get it up into its final location, I've got to drill my pocket hole screws in this way. If I put this in place first, I ain't doing that. So I'll put this in location, get it affixed in final location, get that set up. Once everything's set up, level squared, all that, I'll come up here and take this and put this in and screw it in. I did pocket hole screws on the front side of this one so that it was easier rather than trying to do it from the back. This is going to be covered up with finish anyway, so I'm not worried about it. So I got this set up with a specific intent and purpose, and I hope it works the way that my mind says it will, and I guess we'll find out. But I built this cabinet. This right here provides a feed through into the front part of the bus so that I can route cables and stuff. If you come back here, I've got this cutout right here for that same purpose so that I can route cables this way. This is to the back of the bus, so I'll be able to route my internet cable or Ethernet cables out the back and down the back of the bus. My link for my switch and my distribution cables for the front. I put these right here so that I could maximize the space in here and allow me to actually wall mount some things, floor mount other things, and give me plenty of room for proper cable management and all of that. My excuse me, my Starlink and my hotspot cables will actually come through back here at the back. If you can see that right there, my WAN inputs will come in through here and come around through the front right here, and then they'll connect to my router. And I haven't decided where I'm going to mount everything, but that's going to determine the proper location. But and then my front distribution switch will go in here, power supplies will go in here, Starlink will go in here. I was supposed to get a wall mount kit for my Starlink. It was supposed to show up today, but it didn't. So I'll have to wait for that, so that because I do plan on mounting the Starlink up on one of these plates, depending on where the best location is. Probably this one because it might extend. I'm not using the Wi-Fi component of the Starlink, so that shouldn't matter. But this is my equipment cabinet. I've got a nice, neat little cubby hole for it. So let's take a walk up to the front of the bus and I'll show you where this is going to go. Going right there, y'all. That's where that thing is going. So it is going to go from here. If you remember the pocket holes I said that I needed to get put in before I put that other plate, they're going to go in right here into this. And then my 4 inches back, my other one will be coming out here, and then from there back will be the actual floor of the equipment cabinet. It sits about a 1/2 inch above this. I got this here to try to help me figure out a way to support it. It didn't work, so I'll have to come up with something else. I'm going to put something back here so that I can just do a level square and mount, get it in the right place, because I plan on putting a wall right here, and that wall will actually be the final support for the equipment cabinet. So one of the other things, if you notice on previous videos, one of the other things that I've done is done a lot of cable management and cleanup going through here. Stop right there, because I got a mess. I got to figure out what's going on and try to figure out what I need to do to get it fixed. But as you can see, when I'm done, it'll look like this right here all the way back to the bus. And I need to do that so that I can provide the right space, location, and stuff, so I can route my distribution cables. I've got a link cable that's going to come from the equipment cabinet and go all the way back to my 12 volt equipment cabinet where my other distribution switch is going to be. And then I've got the distribution cables that are run into here, into this area right here. And then I got to figure out a way to get them to the other side so that I can drop some over here as well. And that front switch will take care of everything from the kitchen forward. The back switch that I will put in the equipment cabinet will take care of my equipment cabinet connections and everything in the back room. Back room is bedroom and office, dual purpose area, so I'm going to have quite a few internet connections in that one area. But for the most part, the only thing in the equipment cabinets will be my servos, because they connect to everything else over the CAN, so I don't need to put anything else on the network. I don't know, that I'll have to check. Maybe the inverters have a LAN input, but I'm not sure. Right now, I'm not sure, so I can check and see. I may entertain it if they do, but anyway, so excuse me, that's what I got going on. That's what I've done right now. That cutout that you saw in the back going towards the back of the equipment cabinet is to clear this wiring and provide an output egress point for my Ethernet cables that are going to be going back to the back of the bus. I definitely want to clean this up so that I don't have everything all messed and tangled and all of that stuff as I route it. Want it nice, clean, neat. Spent a lot of time yesterday building the cabinet and working on cleaning this up. I started working on this. I've got to wait to go any further until I figure out where my final mounting locations are going to be. One of the other things that I did too, I was running into a problem with my security system right here. I had it wired, and I'm not sure exactly what was going on, but I had all my triggers wired the way that they said to power. And the problem I had, if you see right here, you've got the regular menu options for the backup camera system, and I got my 4 cameras in my front, my rear, and my 2 sides. For whatever reason, the way that I had it wired, I could not get this up, and so I started troubleshooting and disconnected my trigger wires. So what I did is, because I don't always need this, so what I did was I came over here and I added this switch right here, and if you watch the screen, when I flip that switch, you'll see what happens. All my cameras go up. Backup is primary, and I got front, left, and right, and they stay that way. You cannot access the menu screen or anything as long as that switch is on. It stays that way, and that's all you can see. Going down the road, I don't need to be playing with menus anyway. So I flip the switch and I can see all my cameras, and that's all I see. Turn the switch off. If I need to do any menu options, I turn the switch off, and after a few seconds it reverts back. So kind of like that idea, and I think it's going to work out really well. So that's cool. The other thing that I did is I rerouted my alarm panel, my light panel. I'm going to put that right up here in the corner, and got that out of the way. This wire right here is all the power. So green is internet, so that's for my power supplies. That will provide the PoE and all the other connections for Starlink and Wavlink and all of that. Black is obviously ground, and this is going to be for all of the USB connections that I need to make up here for my security cameras, iPhone, iPad, anything else up here that I want to plug in that may be USB will be on that one. Coming over here, I didn't show you this previously, but there is the door camera. There's the door camera USB connection right there. So that is the USB output that is providing power to my front door security camera. I've got the same thing in the back as well. I've got a 2-port and a 1-port. The 1-port is just like this. The 2-port is a round one. This also has a USB-C input as well. I've got the USB-A connection used for the cameras. They're all USB-A. But I do have a USB-C, so I could connect a USB-C device to this as well. Alright, so that's a rundown of the overall equipment, what I'm going to do, what my plan is, how I hope it's going to work, where it's going to go. The last thing that I want to show you is let's take a walk to the outside of the bus, because one of the things that I did get is I got the mobility mount for my Starlink antenna, and I want to show you how I put that in and how I've got that mounted. So let's take a walk to the back of the bus. There it is, Starlink on the roof, ready for data in motion. If you look underneath, I've got the mobility mount sitting there. There's a ton of videos about the mobility mount and all of that stuff. I do want to show you some unique things that I did to get that mounted. But there it is. Here's the plan. If I'm rolling down the road, Starlink will be on the mobility mount. I will route the cable up the solar panels over to that corner, over to here, at which point it'll drop down, route underneath all of the solar panels up to the front. If you see in the distance that mast that's coming up right between the two stacks, that is where my Wavlink Wi-Fi extender goes. That will actually sit in there, and the antennas and everything will extend up. I think I measured it, and at full extension it's like 16 feet above the ground. So the cables will run from here over to here, down under, and up to there, go through the roof, and then connect to the Starlink router. Now the reason that I'm doing that, and the reason why it's on top here as opposed to underneath the whole way, is that from this point, what I intend to do is install a mast mount and put a flagpole mount kit that comes up the side of the bus, and then I can pull this cable back that's easily accessible on the top, put my Starlink antenna on the pole mount, connect the cable up to it, and extend my pole, which based on the installation would be 12 feet above the roof of the bus. So I will be able to get my Starlink antenna 12 feet above the roof of the bus. I'll be able to align it, I'll be able to set it up, hopefully clear obstructions and everything. But I'm doing that so that I can very easily switch between pole and mobility depending on what I'm doing, and have the cable positively secured either way, whether it's on the pole or whether it's in the mobility mount. And it's just a simple transition, disconnect it from there, and I have to pull the antenna off of there anyway to put it on the pole mount. So pull it up there, disconnect the cable, bring it over here, put the antenna on the pole mount with the cable connected to the pole mount, put it in the pole, and raise it up, and good to go. So that pretty much concludes the entire system overview of everything that I'm doing. One of the other things that I do want to share with you is that I've got those two cameras that I showed you that are going outside. If you see that front mast that's up there between the two stacks, that's where the Wavlink is going. I'm going to be putting two cameras up there in that area, not on that mast, but in that area. I'll probably put another one for the cameras. One is going to provide a look downward to the front of the bus, because that's what my one security blind spot. I can't see anything directly in front of the bus. The other one is going to be pointing backwards across the roof, so that if I'm going down the road, if solar panels start shaking, the board starts shaking, max air fan thing starts shaking, my latch here, or my emergency hatch starts shaking, anything, I can have a constant and clear view of everything that's going on the roof. I do intend on putting some railings up here so that I could probably mount and store low profile things on top of the roof. Nothing will exceed the height of the stacks. That's my clearance indicator. I've actually measured it. Ground level to the top of the stack right there is 11'8". that is the maximum that I'm going to go on anything on this roof. Keep everything below the stacks. If anything scrapes or hits my stacks, I know I've got problems, because everything is going to be at or below that level. That's what I got going on. So that is the overall overview of everything. This is probably going to be a several part series, because I don't know that I can finish everything. One of the things that I am going to do is work on getting before I close this video out, I'm going to work on getting everything installed into that equipment cabinet, and then get it all cable routed and secured to show you what that looks like, and actually get that cabinet installed. Once that's done, then it'll be time to start wiring up power and start configuring everything. We'll do a separate video on configuration and testing, and then we'll see how it works. So I'll be back as soon as I can get everything installed. All right, so before we go too much further, I do want to give you a rundown, like I said I would, about how this mobility mount is mounted. I used the back deck behind the Max Air fan to get it out of the way. If you look right here, you can see those are the bolts that go through the mobility mount. Those are all 5/16 bolts. I use this aluminum angle and put rib nuts into the aluminum angle to hold it in place, and then secured those bolts down through the mobility mount into the rib nuts and through the aluminum. Once I got that done, then I did bolt and washer on this side and back there on that side. And what I have done with that is I've spread and distributed the mounting surface for that mobility mount across 1, 2, 3 different boards on the back deck, so that it's not just relying on a connection on one board. So they would all have to come up for me to lose my antenna. So I wanted to give you a rundown on how I did that, and give you some insight. I did the mobility mount on rib nuts because I can remove the mobility mount without removing the angle iron or anything, because of the way that they're set up. I didn't do rib nuts for the other ones, because if I do need to move this or whatever, I'll have the ability to do that if I need to relocate them or whatever. So I did want to give you a rundown. So that's what that looks like for underneath the bus. And you can see what I've got going on there, and that's how I mounted my mobility mount to the back deck of my bus. All right, we're in the bus now, and I wanted to give you a rundown on the work that I've done on my equipment cabinet. So here's my router. It's installed. I do want to clarify a few things that I made a mistake when I was talking about it earlier. So here's my WAN 1, here's my WAN 2. This is a 10 gig port, and these are also 2.5 gig ports. So I thought that both of these were WAN, and they're not. So just a little bit of clarity on that, in case anybody notices that I misspoke on that. But after I installed it and was starting to check through everything, I noticed that. Here is the power supply for the Starlink router, which is right here. Here is my front side distribution switch. I've got my cable connected to it. I've got power routed to it. PoE injector for my Wavlink. I've got the power routed to it. Power is also connected and routed to this. I don't have power on it yet. I just got all the wiring run. Here is the 54 volt regulator for all of the other devices that are not Starlink, which would be my router and my PoE injector. If I look back here, I got here are the primary power inputs that'll come from my power source that'll provide power to everything. I just pull those out, drop the wires in. I've got them run up there in the front of the bus and already connected. I just connect them up and put some fuses in, and everything will have power. Next step for me is to work on doing some other stuff up front to get ready for this, so that I can get it installed. But I wanted to give you a rundown on the fact that everything is in. If you notice, I do have the wall mount for the Starlink router installed there as well. So that's in place. And now we're going to take a walk outside the bus, and I'm going to show you one other thing that I got done. All right, now I'm outside the bus, and I do want to show you what I got going on here. If you see this little bracket that I got going on right here, I've got butyl tape behind it to seal it up and stuff. I've got silicone sealant in the bolt holes that go through the wall of the bus as well. But if we follow that up, we can see that I have a Starlink antenna mount way up there in the air. I got my flagpole in. I got 2 8 clamps around the pipe there to secure it in opposite directions. Did that for some added security. I also put this, I was intending on putting it back here, but I put it right here because it's close to the unistrut and it's much more stable and supported, as opposed to going back here. So that's why I put that there. Guys, I had to do some serious engineering to get this to work. I am not going to lie. This white piece of pipe that you see right here is actually the flagpole support that goes into the under wheel mount that they provide with the flagpole. You roll the wheel over the top of it, drop the flag in, and it's secure. Up at the very top, you can't really see any detail on it, but when I bring it down, I'll run through some detail on exactly how I built it. But I've got a lot of different stuff going on up there too. The entire flagpole is stationary and non-movable. If you see, I don't know if you can see in the video, I can't right now, but at the specific joints of the pipe where they extend out, this flagpole was friction lock, and I didn't like that, so I drilled holes and put 1/4 inch bolts through with some wing nuts on them. The only thing they're there for is to prevent the flagpole from collapsing. It will not be up like that when it's driving down the road. It'll be down. One thing that I did notice is with the flagpole down, I've increased the overall clearance requirements of my bus by a couple of inches, but I'm not going to worry about that. So I got that done. I got to wrap this up because I'm about to get hit by a severe thunderstorm. And so with that, I want to wrap this up. I'll call this one part 1 as a system overview, and we'll get this one out, and then I'll move on, and we'll start getting that stuff installed and get it powered up and configured. Thank you for being with me. Please like and subscribe.